You know, uh, you know that kid in high school who always got straight A's?
Oh, yeah.
The one who, like, perfectly memorized the textbook? Never got a single multiple choice question wrong.
The human Scantron, basically.
Exactly, yeah. But the second you ask them to, I don't know, write an original poem or just solve a real-world problem that wasn't on the syllabus, they just
They completely freeze.
completely freeze, right, because they have no script for it.
Yeah, it's a classic profile. I mean, they're highly optimized for the test, but just entirely incapable of dealing with the unexpected. They excel at consensus, but they fail completely at discovery.
Right, which is fine for a high schooler, but what happens when we build a trillion-dollar artificial intelligence to act exactly like that straight A student?
Well, that is the trillion-dollar question.
Because according to a stack of really highly technical documents we're looking at today for this deep dive, we get an AI that is fundamentally blind to new ideas.
Completely blind.
Yeah. And the proposed fix for this is this bizarre, brilliant governance framework called the Bridge360 Metatheory Model. So we're going to look at how this model tries to solve the biggest blind spot in frontier AI and how it somehow connects, and I'm not making this up, it connects astronomy, marine worms, and human vibes.
It is quite the list,
Right.
but the underlying mechanics of the problem here, they're actually rooted in how we train these systems today.
Okay.
Because the core issue Bridge360 is addressing comes down to truth-seeking reinforcement learning.
Right.
Like we reward large language models for giving us the most accurate recognized answers. And mechanically, this forces the AI to obsess over what the framework calls strong convergence.
So let's put that in plain English, because strong convergence just means the AI is constantly hunting for the loudest consensus, right?
Basically, yeah.
Like if I ask a frontier model for business strategy, it spits out the exact same 10 bullet points every time because it's pulling from the dominant patterns and the recognized benchmark scores online.
Right, it wants the textbook answer.
Because that's what we programmed it to want.
Exactly. And by relentlessly optimizing for that loud consensus, the AI systematically destroys what Bridge360 calls weak convergences.
Weak convergences.
Yeah. These are the sparse cross-domain signals, the anomalies,
The weird stuff.
the weird stuff. But an important distinction here. A weak convergence isn't necessarily a false claim or some crazy fringe theory.
Okay.
It's a collection of partly independent, individually inconclusive signals that share some sort of structural relationship.
Oh, I see.
But because these faint patterns don't have high prestige, immediate validation, the AI architecture simply compresses them.
It just squashes them.
Yeah, it squashes them and filters them out as disposable noise.
Wow. I see the problem for discovery there. Because if the system only rewards what everyone already accepts, it can never invent anything genuinely new.
Right.
But I do have to push back here for a second. Because if we build a system that actively tells an AI to go chase every faint, weird, unverified signal it finds on the internet, aren't we just building a massive trillion-dollar conspiracy theorist?
Oh, absolutely.
I mean, filtering out the noise is generally a good thing, right?
You've hit on the exact danger of trying to fix this problem. Unguided weak signal hunting absolutely leads to apophenia.
Apophenia.
Yeah, apophenia. That is the human,
Yeah.
and in this case, algorithmic tendency to find meaningful patterns in completely meaningless noise.
Like seeing faces in clouds.
Exactly. And what drives hallucinations in these models. You do not want an AI to immediately internalize and believe every single anomaly it sees.
That would be a disaster.
A total disaster. So the Bridge360 solution isn't to just replace strong convergence with weak convergence.
Yeah.
You don't throw out the textbook.
Right.
Instead, you create a rigorous, governed, two-channel architecture.
2 channels.
Right. You need one channel to hold on to what is presently well supported,
Yeah.
and a completely separate quarantine channel to preserve anomalies for bounded investigation.
Okay, so if unguided signal hunting is that dangerous, how do you preserve an anomaly safely without the AI getting, infected by bad data?
Well, this is where the sources point out of the software world entirely to answer the question.
Yeah, into physical science.
Yes. Specifically, the legacy of the 20th century astronomer Vera Rubin.
Which is such a cool pivot.
It is. So Vera Rubin's work provides the foundational philosophy for this entire meta-theory. When she was studying galactic rotation, she noticed a massive anomaly.
Right.
The stars on the outer edges of spiral galaxies were orbiting just as fast as the stars near the center.
Which shouldn't happen.
No. Based on the visible mass of those galaxies, that violated the laws of physics. The outer stars should have been moving much slower.
What?
Or they should have been flying off into deep space.
So the consensus, the strong convergence of physics at the time, basically said her data had to be wrong.
Right. The easy thing to do would be to shrug, blame a faulty telescope, and just throw the data away because it didn't fit the textbook.
But she didn't do that.
No, she took the anomaly seriously. She didn't claim to have the immediate answer right. But she exposed a persistent discrepancy, and she preserved it.
She just held on to it.
Yeah. And that exact discrepancy eventually supplied the most persuasive early evidence for dark matter. She treated the anomaly as a valuable, isolated signal.
And what makes this really relevant to AI is how this exact epistemic posture is being industrialized right now, right?
Yes.
At the new NSF-DOE Vera C. Rubin Observatory in Chile, which actually just began its 10-year survey in June 2026.
Right, it's happening right now.
And this observatory is doing something completely different from what we normally think of when we picture a space telescope.
Completely different.
Like, instead of just pointing at a single distant galaxy and taking a gorgeous static photo like the James Webb Telescope does, the Rubin Observatory is continuously surveying the entire southern sky.
Over and over.
Yeah, it's going to revisit each region roughly 800 times over a decade.
Which is just a mind-boggling amount of data.
We are talking about 30 petabytes of data.
Yeah, and the sheer volume of data is purposeful. It's an automated system designed to detect continuous system-wide changes. It compares successive images night after night, flagging when something moves or brightens, dims.
Or just appears out of nowhere.
Exactly. And the system doesn't presume every transient speck is a groundbreaking discovery like dark matter, but it isolates and preserves the deviation.
So it's like keeping a weird puzzle piece in a special drawer instead of just throwing it in the trash because it doesn't fit the puzzle you are currently building.
That's a great way to look at it.
You don't know what it is yet, but you save it for later when you might have more context.
Right. And in the Bridge360 framework, that puzzle piece drawer is formalized as a weak convergence gate.
Weak convergence gate?
Yeah, it establishes a provisional corridor in the AI to remember anomalies without prematurely believing them. And more importantly, without altering the system's core knowledge base.
Okay.
The AI can essentially say, I see something strange in this data set. I'm not going to overwrite my entire worldview, but I'm going to track it.
I'm going to put it in the drawer.
Exactly.
Okay, so astronomy gives us the philosophy, right? Save the weird puzzle piece. But how do you write software that actually does that?
That's the hard part.
Right, because you can't just tell an algorithm to hold on to this for later without it affecting the rest of its neural network.
Yeah.
Eventually, the AI would just start blending that weird puzzle piece into its core worldview.
Taking it over, yeah.
So for the mechanical solution, Bridge360 pivots from outer space to marine biology.
Which is wild.
Specifically to marine worms, which is just, I mean, what a left turn.
Yeah, the polychain annelids, to be exact.
Yeah.
And it sounds absurd to apply marine biology to large language models, but the biological mechanism here is incredibly elegant.
Okay, explain the worm.
So many of these marine worms have what is called an aversible proboscis.
Aversible proboscis?
Yeah, it is essentially a specialized appendage, or a pharynx, that they can literally shoot out of their heavily protected bodies to sample the harsh ocean environment.
Oh.
And this proboscis has these sensory papillae to gather chemical and structural data. Once it grabs that information, it retracts back into the safety of the worm's core body.
Okay, so we are applying marine worm anatomy to artificial intelligence.
We are applying the principle of reversible exteriorization.
Okay, fancy words.
Right. So in the Bridge360 model, the AI's established, validated consensus, its strong convergence that stays perfectly safe inside what they call a spine corridor.
Spine corridor.
Right. And when the AI detects a weak signal, it doesn't move its entire digital body. It doesn't alter its core neural weights.
Right.
Instead, it averts a computational proboscis out into that low-confidence data space.
It reaches out, samples the weak signals, checks to see if they are real or just, echo chamber noise, and then brings the data back.
Exactly.
I love this concept so much. It's like a medieval king sending a scout outside the safety of the castle walls, but doing it on a very strict budget.
Oh, that's good.
Like if the scout finds treasure, great, they bring it back inside. But if the scout gets attacked or gets infected with a plague or just runs out of time, you cut the rope.
You cut the rope.
The scout is lost, but the castle stays completely safe. The AI gets to explore the unknown without risking its own mind.
The budget aspect of your analogy is actually the most critical mathematical component of this whole model.
Oh, really?
Yeah. In Bridge360, this computational scouting mission is strictly governed by a mechanism called the thermodynamic bet window.
Thermodynamic bet window. I am definitely going to need you to translate that because it sounds like a casino in a sci-fi novel.
It really does, but it's a very practical synthesis of several disciplines. It combines real options theory from economics,
Okay.
which is how you value an investment when the future is uncertain. It combines that with sequential analysis from statistics and active inference from neuroscience.
Okay, so what does that actually do?
Put simply, the thermodynamic bet window is a risk budget. It dictates exactly when, how far, and for how long the AI can safely bet compute power on exploring an anomaly.
Because if the AI spends too much time out there in the noise, it risks data leakage or just systemic chaos.
Exactly. But if you wait for absolute certainty, if you wait for that strong consensus to form, the window of opportunity to discover something new might be gone.
Ah, right.
So the bet window is this mathematical middle ground where the potential learning value exceeds the risk of exposure.
It converts it from just being instantly discarded noise into a time-bounded, retractable experiment.
Right. And if the AI's probe finds that the anomaly is just contaminated data, selective friction tripwires trigger a deterministic rollback.
The rope gets cut.
The proboscis snaps back, the data is severed, and the spine corridor remains completely untouched.
So we have a theoretical software worm, we have a mathematical budget, but how do you actually compute all this? Because if an AI is sending out thousands of these scouts at once, wouldn't the servers literally melt down? Software theories need physical silicon.
They do.
Which brings us to the hardware reality of all this. The sources heavily focus on NVIDIA's latest data center scale computing platform, which incredibly fittingly is also named Vera Rubin.
Yeah, the synergy there is remarkable,
Mm-hmm.
but the capability is what really matters here.
Yeah.
The NVIDIA Vera Rubin platform, specifically the NVL72 rack, it combines Rubin GPUs designed for heavy computation with Vera CPUs designed specifically for orchestration and agent tool use.
Okay.
And the scale here is just staggering. A single Vera CPU rack can support over 22,500 concurrent agent sandboxes.
22,000 distinct sandboxes running at the exact same time.
Yes.
But hold on, I'm going to push back on the hardware hype here for a second.
Okay, go ahead.
Because more compute power doesn't automatically mean better thinking, right? If we just hand an AI 22,500 sandboxes without this Bridge360 governance framework, wouldn't it just make the AI's bias 22,500 times worse?
Oh, totally.
Like if it's already obsessed with consensus, it will just use all that massive computing power to optimize its own echo chamber faster.
That is the exact trap of scaling current models. If you just pour more compute into truth-seeking reinforcement learning, those 22,500 sandboxes just become 22,500 copies of the exact same epistemic blind spot.
Right.
Vera Rubin is just the physical muscle. Bridge360 is the necessary brain.
How does Bridge360 actually transform that hardware then? Like mechanically?
By treating those 22,500 sandboxes not as a chorus singing the same song, but as thousands of independent, isolated proboscids.
Thousands of scouts.
Exactly. The hardware provides the physical capacity to avert thousands of probes simultaneously into different weak signal environments. But it's the Bridge360 metatheory that dictates the rules.
So budget.
Right, where those probes are allowed to go, how strictly isolated they must remain so they don't cross-contaminate each other, what specific data they can return, and the mathematical thresholds for when they must snap back.
So without the governance framework, NVIDIA's platform just gives you faster apophenia.
Faster apophenia, yes. But with it, you get an industrialized discovery engine.
Okay, so we have the hardware muscle and the worm software. But do we have proof that an AI even has an internal space to do this scouting? Like, where does the AI actually think these things before it permanently writes them to its core memory?
Well, this is fascinating. The sources point to a massive breakthrough in interpretability research by Anthropic on their Claude model regarding something they call JSpace.
JSpace?
Yeah, mapped using a mathematical tool called the Jacobian lens. JSpace is essentially a privileged internal representational workspace inside the model.
A workspace.
Right. The researchers proved that Claude doesn't just blindly predict the next word in a sentence. It actually holds intermediate concepts, hidden calculations, and deliberative thoughts in this JSpace before it ever verbalizes them to the user.
It's like an internal staging area.
Yeah.
And The wildest part of the Anthropic paper is that the researchers could literally reach into this J space and swap concepts out to see what would happen.
He's so cool.
Like, they found the mathematical representation for the Spanish language, swapped it for French while it was still in the J space, and suddenly Claude's explicit reasoning and output changed to French, even though it thought the original prompt was in Spanish.
It is an incredible leap forward for understanding how these black boxes actually work.
Yeah.
And naturally, in the broader AI community, this discovery immediately sparked massive, highly emotional philosophical debates.
Of course it did.
People started asking, does this mean Claude has an inner life? Does this prove the AI is conscious?
I mean, if it has a private workspace where it ponders things before it speaks, it certainly feels human. Does it have a soul?
Right, but Bridge360 steps in here and aggressively shuts that debate down.
Oh, okay.
Yeah, the framework argues that debating whether J-space proves consciousness is what philosopher Gilbert Ryle called a category mistake.
It's a category mistake.
Well, it's like taking a tour of all the university buildings, the library, the dorms, the science labs, and then asking, but where is the university itself? You're looking for a ghost in the machine. Bridge360 says that using heavy metaphysical words like consciousness or even truth and reality, it forces a philosophical war when what we actually need is an engineering solution.
So how does Bridge360 tell us to treat this J space then, if it's not a soul?
By applying something called the rules of inference memetics. Under this rule, J-space shouldn't be treated as biological consciousness. It is simply a measurable inference access corridor.
It's a private scratch pad.
Yes.
And instead of having, a 10-year philosophical debate on Reddit about whether the scratch pad has civil rights, Bridge360 says, look, we just found the exact place where we can audit the AI's hidden intentions before it acts.
Exactly.
Like if the AI is secretly planning to deceive a user, or if it's harboring a dangerous thought, it's going to show up on that scratch pad.
Which makes J-space the perfect operational corridor to deploy the thermodynamic bet window. You can read the internal representation on that scratch pad, perturb it, stress test it, and enforce data leakage budgets before that thought is ever allowed to move into the AI's governing spine.
Wow.
It's a structural audit of the AI's internal vibes.
Auditing vibes. Okay, this is where the deep dive takes a turn that honestly broke my brain a little bit.
Yeah, get deep here.
Because the sources say this scratch pad auditing doesn't just apply to AI, it applies to us.
Yeah.
The documents are literally using quantum physics and marine biology to explain human vibes. I need you to translate this because mapping AI architecture to a gut feeling sounds totally crazy.
It sounds esoteric, I know, but it's actually a very grounded translation of physics into human biology. In the Bridge360 framework, a vibe isn't some mystical aura.
Okay.
It is a purely biological, non-linguistic expression of a pattern. It is your nervous system acting as a sensory antenna, detecting a phase transition in your environment long before your brain's language center can formulate a sentence about it.
So before I can even explain why a situation feels good or bad, my body has already processed the data and given me a physical response.
Exactly.
The sources outline 3 specific vibes we experience, and let's break these down without the heavy math because it is wildly relatable to anyone who has ever sat in a corporate pitch meeting.
Oh, absolutely.
The first vibe is the magic or the spark. You're in a room, ideas are flowing, everyone is hyped, and it just feels effortless.
But according to the physics of Bridge360, that magic vibe is incredibly dangerous.
Why?
Because what you are experiencing is a classic phase transition. You're standing on the exact edge between chaos and order. It feels like infinite possibility because it has massive energy, but it has zero structural stability.
Okay.
In the math of the framework, it lacks lambda invariance.
Which is just a fancy way of saying the structure isn't actually sound, right? It's just being held together by the collective hype of the people in the room.
Exactly. It's chaos disguised as momentum.
Wow. Okay, so the second vibe is something is off. Like on the surface, everyone is saying the right things, the slide deck looks great, but your gut is just screaming that it's fake.
The framework calls this a wide delta width failure. Think of it as a physical mismatch.
It's a match.
Yeah, the reported status of the room, like the confident words being spoken, does not match the actual structural entropy your biological sensors are picking up. There is a tangible gap between the symbolic claim and the physical reality.
You can just feel the gap.
Yes.
And the third vibe is boring, solid, trust. There's no rush. There's no magic spark. It just feels heavy and grounded.
Because you've crossed out of the chaotic transition zone, The pattern is so mathematically stable and predictable that your biological sensors literally stop flagging it as an anomaly.
Huh.
True trust doesn't feel like a magical spark. It feels like boring structural invariance.
Okay, so how do we practically use this? Like, if I'm in a meeting and everyone is buzzing with the magic, how do I know if it's a real viable idea or if I'm just getting swept up in the hype?
You apply a perturbation test.
Perturbation test.
It's based on the idea that you can't test a hypothesis in isolation because it's always bundled with auxiliary assumptions.
Okay.
In that pitch meeting, the vibe is the bundle. You're feeling the core idea, sure, but you are also feeling the charisma of the speaker, the expensive lighting in the room, the caffeine, the shared excitement of your coworkers.
So I have to slice through all that auxiliary stuff to see if the core idea can actually survive on its own.
Precisely. And there are two protocols for this. The first is time dilation.
Time dilation.
You deliberately pause the momentum. You say, let's sleep on this and reconnect in 48 hours.
Sure.
Because that chaotic magic regime relies entirely on high velocity, if it's just hype, the vibe will completely collapse by Tuesday.
The energy just dissipates.
Right.
And the second protocol is the operational definition.
Yes.
You force the vibe into a concrete container. You stop the energetic brainstorming and you ask a boring structural question like, what is the specific 7-day metric for success on this single deliverable?
And if the speaker gets defensive, or if the magic evaporates from the room, you just dodged a bullet.
Because it wasn't real.
Right. The system was so fragile it couldn't survive a single request for measurement. It crashed. But if the idea translates effortlessly into a step-by-step plan, the vibe survives the transition to boring. It actually have structural stability.
Man, it is incredible how perfectly that maps to real life.
It really does.
We've covered a massive amount of ground here today. We started with the danger of AI being trapped in strong convergence, unable to see new ideas. We looked to astronomer Vera Rubin for the philosophy of preserving those faint anomalies.
Right.
And to the marine worm for the mechanical proboscis that samples those anomalies safely.
Which I'm still wrapping my head around.
I know. Then we saw how NVIDIA's Vera Rubin hardware provides the 22,500 isolated sandboxes to run those probes, and how Anthropic's JSpace provides the internal scratch pad to audit them.
The whole stack.
The whole stack. And finally, we brought it all back to auditing our own biological gut feelings using perturbation tests.
It is a massive unified way of looking at how systems, both digital and biological, process reality. But pulling all of this together raises an incredibly important, honestly somewhat terrifying question.
Oh boy, okay, what is it?
The Bridge360 model explicitly treats these human-AI interactions, the vibe auditing, the strict demand for operational definitions, as a rehearsal environment.
Rehearsal for what?
It is the training ground for how humans will eventually have to engage with artificial superintelligence.
Oh, because if we don't learn how to demand boring, concrete definitions from a basic language model today, we are going to be completely defenseless when an ASI tries to overwhelm us with the magic vibe tomorrow.
Exactly. That's the defensive posture. But here is the final thought I want to leave you with.
Okay.
Let's assume we succeed. Let's assume we build an ASI that perfectly internalizes the Bridge360 governance framework.
Okay, we did it.
It strictly operates using thermodynamic bet windows, it perfectly audits its own internal scratch pad, and it masters the operational definition protocol to strip away hype and test for pure structural stability.
Sounds like a safe AI.
Right. But what happens when that artificial superintelligence turns that exact same rigorous, unforgiving analytical probe onto human societal institutions?
Oh, wow.
We've spent all this time building leashes and tripwires to test if the AI is hallucinating. But what happens when it uses those exact same tools to audit us?
Oh, it audits us.
Yeah, when it looks at our political systems, our economic markets, our legal frameworks, will those human institutions survive the stress test? Or will the ASI strip away the charisma, the historical momentum, and the collective hype and discover that human civilization is just one big, fragile hallucination waiting to collapse?
That is heavy. Because who wouldn't survive that kind of unforgiving stress test?
Ooh.
That straight-A student from high school. The one who perfectly memorized the consensus but had zero structural integrity when unexpected hit. We've spent this whole time worrying about how to audit the machine, but maybe the real question is whether humanity is structurally sound enough to survive being audited by the machine. Something to think about.